Welcome to electricalworld360.com. In this video, we are going to solve the most important MCQs of DC machines for SSC, and this is the part 1 video of this series. So before we start, if you are new to the channel, then please subscribe our channel, and if you want, you may follow us on Facebook also. We are also available on Telegram, and usually whatever video I make, I used to upload all the PDFs in this channel. So if you want, you may join us on Telegram by searching here. You can search here Electrical World 360 official, and otherwise if you want you may join our channel through this link also. So this is the question number 1. Two DC series motors are connected in series to produce torque T. Now if the motors are connected in parallel, the torque produced will be T by 4, T by 2, 2T, 4T. So in this case, as we know, for DC motors, torque equal to K theta Ia. Theta is the constant, T is the torque, and K is the constant, and theta is the flux, and Im is the armature current. So for DC series motors, T is proportional to, that means theta is proportional to Ia, flux is proportional to current. Okay, so we can write this equation like this way: T equal to K, that means a constant. We have written it like this way: I instead of theta, that is current into current. So T equal to K into I square. Okay, so from here we can say it like this way also: T is proportional to I square. So we are considering it like this way. Suppose this is the series connection, and this is the motor 1, and this is the motor 2, and this is the motor A and motor B. Okay, so and if these are the supply point, okay, so the motor A is getting I current and motor B is also getting the I current. So the input power is Vi. Then for motor 1, the torque of the motor A and the equal to the torque of the motor B equal to the total torque, that is the K theta I. So we can write it like this way also: T equal to K I square. So we are taking it like equation number 1. And for parallel connection, suppose this is the M1, that means the motor 1, and this is the motor 2. So the motor 1 is getting I by 2 current, and the motor 2 is also getting the I by 2 current. So we can see it like this way: T parallel is proportional to theta into I by 2. Why I by 2? Because each motor for parallel connection is getting I by 2 current. So the T parallel is proportional to I by 2 instead of theta, because as we know, the flux is proportional to current. I by 2 into I by 2. We can also write it like this way: T parallel is proportional to I square by 4. So T parallel will be is equal to K into I square by 4. So suppose this is the equation number 2. You can see it like this way: TP, that means the torque of the torque for parallel connection, is equal to Ki square by 4. So as we know, at the time of equation number 1, we have seen it T equal to Ki square. So T equal to Ki square. So we can write TS, that means torque for torque for series connection, instead of Ki square. So from there, from the equation number 1 and 2, we are getting like this way: TP is equal to TS by 4. TP means the parallel torque for parallel connection, and TS means the torque for series connection. Okay, so TP is equal to TS by 4. So in question we can see it, the option number A is the right answer, T by 4. So this is the question number 2. Which DC motor is generally preferred for cranes and the hoists? Series motor, that means DC series motors, DC shunt motor, cumulatively compound motor, differently compound motor. So as we know, for cranes and hoists require the high starting torque. For the higher starting torque requirements, the DC series motors or the three-phase induction motors are used. So that means wherever is high starting torque is required, we use either DC series motor or three-phase induction motor. Okay, but for practically for traction or railway applications, DC series motors are used. And in this case, here the option number A is the right answer. DC series motor is generally preferred for cranes and the hoist. Okay, so this is the question number 3. A synchronous phase modifier as compared to a synchronous motor used for mechanical load has the larger shaft, higher speed, smaller shaft, higher speed, larger shaft, smaller shaft, and the smaller speed. So in this case, we should know synchronous phase modifier is nothing but over-excited synchronous motor operating at leading power factor and used for voltage control. This differs from a normal synchronous motor as it has no external load on shaft due to which it has smaller shaft. Also, for no load, the motor can operate at highest possible speed. So, for synchronous phase modifier, the design consideration parameters are smaller shaft and higher speed. So that is why here the option number B is the right answer. This is the question number 4. For traction work, which motor is preferred? Synchronous motor, three-phase induction motor, DC series motor, universal motor. As I discussed earlier, for traction purpose, DC series motor is used. So that is why here the option number C is the right answer. So these are the online courses. If you are preparing for SSC, GATE, ESE or the coming IRMS 2021 and other competitive exams, and if you are from electrical engineering department, then these courses are for you. In course number 1, you are getting 12,000 plus MCQs with video solutions. That means solutions will be provided to you in the form of video. And in course number 2, you are getting 22,000 plus MCQs with video solutions. That means the solution will be provided in the form of video. Okay, and along with that, you will also get important notes and the shortcut tricks in the form of PDF. Shortcut tricks will help you to remember all the important formulas of electrical engineering and the other things of electrical engineering. I think these courses will help you to crack the exams. So this is the question number 5. Which motor has widest variety of methods for speed control? DC shunt motor, synchronous motor, slip ring induction motor or the surge motor? So in this case, we should know DC shunt motor has the best speed regulation. For variation in load, the speed change is minimum. So we can have a wide range of speed in the shunt motor applications. So in this case, we should remember that speed regulation is equal to no load speed minus full load speed by the full load speed. This speed regulation is low in case of shunt motor. So that is why here the option number A, that means the shunt motor is the right answer. DC shunt motor has widest variety of methods for speed control. So this is the question number 6. For battery charging, which of the DC generator is used? DC series generator, DC shunt generator, short shunt compound generator, long shunt compound generator. So here the right option is option number B. DC shunt generation is used to charge the battery. This is the question number 7. The no load speed of DC series motor is very small, medium, small, very high. In this case, we should know the speed of DC series motor at no load is very high. So, suppose this is the graph of the speed and load. Okay. So here you can see the speed. Suppose speed is this way, and this is the current. You can say current is proportional to load. LOAT. Okay. So you can see it. This is the no load speed region. Okay. No load speed region. So as I discussed, the speed of DC series motor at no load is very high. So it is never started at no load. So here the option number D is the right answer. This is the question number 8. Area of hysteresis loop represents the copper loss, eddy current loss, dielectric loss, the hysteresis loss. In this case, we should know the higher the area, higher the hysteresis loss. For air, the hysteresis curve is straight line and hysteresis loss is 0 in air core. So here the option number D is the right answer. The area of hysteresis loop represents the hysteresis loss. This is the question number 9. Interpoles are meant for increasing the speed of the motor, increasing counter EMF, strengthening the main field, reducing sparking at the commutator. So here the right option is option number D. Interpoles are meant for reducing sparking the commutator. So in this case, we should remember that interpoles are used to reduce the effect or armature reaction, and also interpoles are used to nullify the effect of induced EMF generated in the coil undergoing commutation. Due to this EMF, the sparking occurs, and the interpoles help in reducing the sparking occurring at the commutator. So that is why here the option number D is the right answer. Interpoles are meant for reducing the sparking at commutator. This is the question number 10. A 4-pole 1200 rpm DC lap wound generator has 1520 conductors. If EMF of generator is 608 volts, 304 volts, 152 volts, and the option number D is 76 volts. In this case, we should know that the EMF generated, that means E equal to P theta Zn by 60A, where the P is, that means the number of poles, P is the 4, here I am writing it here, P is 4, and theta is, that means the flux is 0.01 Weber into Z is 1520, you can see here the number of conductors, into here P theta Zn, and N is, the speed is 1200 rpm, and by the 60A. A means for lap winding we can write it, that means the number of poles, that means the 4. Here the number of pole is 4. equal to E. So by solving it, we will get 304 volts. Okay, so that is why here the option number B is the right answer. This is the question number 11. The connection for a maximum power output from DC motor is EB equal to V, EB equal to V by 2, EB equal to 0, EB equal to V by root 2. So here the option number B is the right answer. EB equal to V by 2 is the right answer. For motor it is E equal to V by 2, and for generator it is V equal to E by 2. Okay. So this is the question number 12. The Swinburne method of testing DC machines. The shunt machine is run as a motor at full load at rated speed and rated voltage. Generator at full load at rated speed and rated voltage. Generator at not load at rated speed and rated voltage. Motor at no load at rated speed and rated voltage. So here the option number D is the right answer. In Swinburne method of testing DC machines, the shunt machine is run as a motor at no load at rated speed and rated voltage. So this is the question number 13. The brushes of a DC machine should be physically placed on the armature in the polar axis, armature in the interpolar axis, commutator in the polar axis, commutator in the interpolar axis. So brushes of DC machines should be physically placed on the armature in the interpolar axis. Okay, and suppose these are the this is the N pole and this is the S pole, and these are the brushes. Okay, that means the interpolar axis will be the right answer. So here the option number B is the right answer. Interpolar axis, armature in the interpolar axis. This is the wrong answer. Option number D is the wrong answer. And this is the question number 14. A DC shunt generator is delivering 500 ampere at 220 voltage. The shunt field current is 10 ampere. The armature resistance is 0.1 ohm. The stray power is 5000 watt. The efficiency of the generator is 91.09%, 95.82%, 95.64%, 91.82%. So in this case, we can write the equation like this way. Armature current is equal to the ISH plus IL. So here the ISH, that means the shunt field current is 10 ampere plus the shunt generator is delivering 50 ampere and 500 ampere. So here will be the 500. So total will be the 510 ampere. That means the armature current is 510 ampere, and the power output is 500 plus 220. That means this is the current and this is the voltage. That means 110000 watt. That means 110 watt. 110 kilowatt. Sorry, that will be kilowatt. So the armature copper loss is 510 square into 0.01 equal to, this will be 2601 watt. Okay, so we can write it also like this way, 2.601 kilowatt. Okay, this is the armature copper loss, Ia square or copper loss. Okay, and the shunt field copper loss is 220 into 10. That means this will be 2200 watt. It will be, we can write it like also this way, 2.2 kilowatt. Okay, so the stray power loss is, I am writing it here, stray power loss is 5000 watt. That means we can call it like this way, 5 kilowatt. So the efficiency of the generator is 110000 by, because this is the power output, by the input power. Input power means 110000 plus 2200. We are getting it from here, and plus 2601 plus 5000, because the 2601 is the armature copper loss and the 500 is the, you can see it here, the stray power, and 2200 is the shunt field copper loss. So these are the losses. Okay, this is the output, this is the output. So as we know, the efficiency is equal to the output by output plus losses. That means that this is the output plus losses means, output plus losses means this is the is equal to input. So output by input is equal to the efficiency. So this will be near about 91.82 percentage. We will find this after solving this equation. 110000 by 110000 plus 2200 plus 2601 plus 5000. After solving that, you will also get 9108 percentage. So here the option number D is the right answer. So this is the question number 15. The MMF produced by interpole is proportional to field current, armature voltage 1 by field current. So in this case, we should know the interpole winding have the series connection with the armature winding. So the same armature current flows through them. That means, suppose we are taking it, interpole MMF is equal to N into Ia. N is here the constant, so we can write it like this way, interpole MMF is proportional to Ia. So that is why here the option number B is the right answer. The MMF produced by interpole is proportional to current, armature current. Here you can see it, Ia. Okay, so this is the question number 16. The maximum temperature limit for class F insulation is, here it is the option number D, 155 degree centigrade. So coming to the next question, this is the question number 17. Match list 1, that means that in list 1 you will get the type of the motors, with list 2, that means the characteristics. In list 2 you will get the characteristics and select the appropriate response. So in list number 1 you are getting the DC series motor and DC shunt motor. In list number 2 you are getting constant speed and the highest starting torque. So as we know, DC series motor starts with the high starting torque, has the high starting torque, and DC shunt motor has the constant speed. So that is why A will be 2 and B will be 1. So here the option number B is the right answer. Okay. So this is the question number 18. The motor characteristics best suited for traction purpose are those of DC series motor, synchronous motor, induction motor. Induction motor means we can take it like 3-phase induction motor or single phase induction motor. Induction motor means it can be any one of these two. It can be 3-phase induction motor or it can be single phase induction motor. And the option number D is the DC shunt motor. So here the option number A is the right answer. DC series motor is the right answer. So this is the question number 19. A lap owned DC generator having 250 armature conductors runs at 1200 rpm. If the generated EMF is 200 volt, then the operating flux of DC generator is what? So in this case we can write it like this way. As we know, E equal to P theta Zn by 60A. So here in question, as we know, N equal to 1200, we can see here N equal to 1200 and Z equal to 250 and E equal to 220 voltage. That means the generated EMF is 200 voltage. Okay. And A equal to the P, because this is the lap winding. It has the, this generator has the lap winding. So 200 is equal to theta is the flux into 1200, that means which is given on the question, 1200 into 250 by 60A. So here the 1200, that means 1200 is the speed of the generator and Z is the 250, that means that this is the number of conductor, and into P into A. And as we know, for lap winding A equal to P, so we can cut this both. So from here, after solving that, we will get theta equal to 0.04 Weber. So that is why here we can see it in the option number B. Option number B is the right answer. This is the question number 20. The highest speed attainable by DC shunt motor is much higher than no load speed, much lower than no load speed, ideally infinite, equal to no load speed. So here in question number 20, we should know shunt motor regulation is very low. If it is 0, that means in ideal case, then the speed of the motor at any load will be equal to no load speed. So that is why here the option number D is the right answer. And if you have liked our video, then please press the like button and share it with your friends also. And if you are new to the channel, then please subscribe our channel, and best of luck for your upcoming exams. Thank you.